But now it is my great pleasure to introduce you to our first speaker, Dr. Esmita Kane. And Dr. Kane holds a PhD in chemistry and a BEd in science. And she is a residential faculty at MCC in the physical science department, and she teaches chemistry. She's been with MCC since 2006 and began mentoring students in undergraduate research projects in 2008, which I would say is probably super innovative for that time. So I think that's awesome. And since 2010, she's been offering research-based assessments that measure student learning. If you've had the pleasure of attending one of Dr. Kane's previous presentations about undergraduate research, then you know that you are in for a huge treat as she shares her ideas on enhancing student learning. So I am just going to hand it right over to Dr. Kane.
Thank you, Lane, for that very nice introduction. Good afternoon, everyone. And it's a pleasure to be sharing what I employed in my semesters with students and what seemed to work in a very exciting level. So without ado, I'll just start presenting. Can everyone see the screen? All right. So undergraduate research as an alternative assessment practice. So typically we have to have assessment in education because our endeavor is to teach and communicate information, positively bring about changes in students, and then at some point the closure is needed. And I think assessment is absolutely mandatory and necessary for the closure of this endeavor called teaching. We do have some practices that are very rampant and common, and they are time-tested exams or quizzes and essays for a subject like STEM or maybe other subjects too. It's lab reports. And then there's always the peer assessment where we have the groups working and self-assessment as well. All the literature that you study on the assessment or even your own experience, my experience tells me that assessment is equivalent to tension, aversion, and low morale. Now, some amount of tension, some people believe is necessary, but when it starts to affect what their goal is to enter an educational institution, I think that's when they start either dropping out or they start getting uncomfortable in this whole system. And I think that just reminds me of this next slide. This was a part of a poster presented by the Graduate School of Education in Harvard. And they have a project, they have thousands of projects. And one of the projects that I've been following is PZ50, which is what they call it. And this paragraph just got me. And we definitely need new nets. We have different types of fish, as I believe we've got variety of educational level students coming in. And if we follow the same traditional methods that we have been following, we probably are either going to miss them or give them an impression of education, which it is really not. And hence, in a quest of finding new nets, I bumped into a student who was having DRS issues, and I just got into this concept of let me give him something to do, which is of the competency, but see how he does it. And he just did it fantastic. And that's where I started getting into this. And then I started reading about it and realized that, well, I'm not the only one who's invented this. This has been going on at a very smaller level or innovative level at many places like here. So what is this as a practice? So if you go to any instructional pedagogy literature or websites or blogs or emails about assessment at higher education, specify higher education, because when it comes to schools, it's a different scenario, but for higher education, these words will constantly come into they'll come buzzing around like bees for you. LOA, learner-oriented assessment. Task was as learning task. So giving a work as if some real learning happens through it, like real life examples, case studies, problem solving, and such something that is empowering that student and having experience along with the knowledge. So when you have an assessment practice that involves this, they get excited about it because then that the tension part relieves because they're distracted positively to learn at different ways or how to accomplish it rather than probably sitting in a room and taking a quiz. So they start, since I'm from STEM subject, I put my thing there, but I want to really reassure everybody that this thing is applicable to any discipline. It is not just for STEM. I happen to be from a STEM and I am a chemistry teacher, so I put STEM there, but literally any subject it's applicable to any subject. It definitely builds responsibility because they are authoring something, they are doing a project, it is their baby, it is their thing. So they become really very interested, engrossed, engaged is the word. And definitely they build responsibility. And last but not the least, it's inclusive. We've been talking about this word at variety of platforms. And I see some really nice pictures. I remember a picture where somebody was standing on a ladder and someone was already tall and how they are equivalent. So that's where this comes off as another option of doing UGR. It takes off the pressure of that assessment, which for most of the times is a deterrent to learning because they're already having that sword on their neck, like when is it going to fall and when am I going to get dropped? So we talk about research, but before I get into it, I really want to make sure that we are aware as a background. We may not get into research, but I think it's worthwhile thinking what really this research means. It's not a very distant word, and it is not a word only for people who are doing PhD or, it's not that kind of a word. As I more and more delved into it, I realize it is a huge word. It has lots of layers. And depending on the competency of your students' classes, whether it's a fundamental class or a senior class, depending on your discipline and your students, you can customize that research concept for as far as an assessment is concerned. So I won't go in the details. You can find these words on Google, but I still would like to say basic research will be specifically about, fundamental knowledge base, which is really groundwork. Applied research, we talk about applying that knowledge to some current existing problem. For example, making a vaccine is a basic research, but then applying it to the pandemic or applying it to COVID situation, that becomes an applied thing. Quantitative always means, any kind of data collection using computerized systems to get meaningful data. Qualitative will deal with, let's say, collecting, comparing, or those kinds of information where there's a survey or an interview maybe. And then the mixed research, which is very much done in STEM for sure, is combination of quantitative and qualitative. But apart from this, there is an other research, and those other research are really some words that have come in the last decade. Explanatory research is talking about cause and effect relationships, typically analyzing, giving an article to student to read and they're critiquing that article. That's a type of explanatory research. Exploration is something like a dissertation or a new project, some kind of an effect which no one has done earlier, and they are beginning to explore that, what is the nature of the problem, how it can be tackled, what are the various methods of tackling. So that kind of a approach is exploratory. Descriptive will be literally describing without interfering with a phenomena. It's like a journalist trying to watch what is happening and describing what he or she sees. So that's a descriptive. Like it depends on different disciplines. Maybe some disciplines will require explanatory, some disciplines will have a descriptive kind of a research. Longitudinal is also many times called as diachronic, and that means you observe the set of given observations over a period of time, like for 10 years or like that, over a period of time, you will observe the same thing. Cross-sectional is you only observe it at a given time and for a given community, for a given data, which is also called as synchronous research. And then action research is where research is geared towards bringing about a change, bringing about achieving some kind of a change, like improving a desired outcome or something like that. So this is just a basic, the reason for showing this was, depending on what discipline you are, and you're the best judges as faculty, you can choose which type of research fits you, and then discover and try to form the assessment in that particular field, and which I'll tell you in a minute. So these are some of the activities that STEM exploratory researchers, we do. We tell them literature search, we do case studies, like if something is happening, there's a fish kill in a pond, why did that fish die? What is the toxicity level? So we'll talk about, as chemistry, those will be some of the case studies. Observations of some phenomena, focus group studies or interviews, surveys. These are all examples, for example, of exploration. So when I say doing something new is getting a hold of an issue or a concern or a happening, and then trying to go around it, thinking how we can best analyze and hopefully find a solution. So these are some of the designs that I have designed on my own and applied since last couple of years, and have had some really good experience. So I've divided them into 3 categories, 1, 2, and 3. So what they do, what is the method employed, how are they assessed, and what are the HII? HII stands for high impact indicators, because undergraduate research is also a high impact practice. So what are those indicators? And this has been my observation put in a table. So this is given to the students in the beginning in the syllabus, that there is an option for them to do undergraduate research-based assignment or assessment. And they need to be able to opt out for that. So some students will opt for that. Some students will say, no, I'm going to go with the traditional way. So that's what this first category is. They will be given questions like either critical analysis of a published paper, or they'll be given a multi-question comprehensive problem where there are A, B, C, D, E, F, G, H, like 10 things that I want them to study. And they will attend my lecture. They will be going through all the PowerPoints, all the in-class group activities that we do, so that they are ready to solve this kind of a question. That's the type of research. Students are assessed. They either submit the project paper to me. Now, when they submit the paper, it doesn't have to be a huge essay. You can scaffold questions based on those questions that you would have anyway put in a test. You can put those questions there. You can replace 1 or 2 or rest of the semester with that project, depending on how big that project is. So maybe you can replace 1 exam and say, okay, instead do this project. You don't have to do this exam. Maybe replace a midterm and give a project, something like that. And these are some of the retention related and other HIIs that I have found out that are there for you. The second type is a few of those students are opted not to do the literature-based critical analysis of a published paper, but they actually do an extra lab with me. And this is what some of the students have also done. We gave them some slightly tweaked labs than regular labs, or gave them completely new labs that I designed for them. And then they had to do that, of course, in my presence, because they're undergrads. So they'll be there, I'll be there in the lab, and they'll work there for an extra 1 hour or 2 hours, and they will be completing that project. So it's an extension of the regular lab, or it could be a new lab. And that's also the way they will submit that lab report as a separate lab report. Again, points are earned, and they are either added towards the test of lecture, or they can also be added towards the quiz of the lab. So they can be replaced with that quiz if they want, or they can just not take the traditional quiz and actually submit this lab report, which will have all those questions that I will ask. For example, if it's a stoichiometry lab, I'll put questions on stoichiometry in that lab report for them. The third type of approach is the CURE, which I just did, and I'm a third cohort for that, STEM CURE. CURE stands for Course-Based Undergraduate Research Experience. This requires the entire class to have undergone through this project. And I applied this to my lab, general chemistry lab, and the whole class did the project. They were given different samples, and they did certain analysis, and then they did certain reactions. Everything, of course, competency-based. All these undergraduate activities that I'm designing are strictly competency-based, nothing just from the fluff or from outside. Anyway, they would have done that as a test. They are now doing it as a project. Then the mixed research was there for CURE, and the students are going to submit a huge poster. They're already excited and working on it. They did replace some of the quizzes, some of the lab reports that they would have given to me in place of this lab report that they are going to give. They definitely get to know all these HIIs. Please pay attention to these. There is the knowledge of connection of community. They mature like you will not believe when they do a project versus taking just an exam. They not only understand the subject, but they also become very engrossed. They branch out, they find out information. They come with a lot of information on the table, and it's exciting to see them talk about it or present that in a paper. Because it was lab-based cure, they also grew in their skills. So laboratory skills were there. It gives them a lifetime experience of taking something and me telling them, hey, this is a sample, nobody knows what it is, and you're going to find out. And then, of course, we simultaneously also find out, and then we compare. And then it definitely initiates that interest. The fourth type of design that is very common is the special project section. This is for slightly senior students. I won't go for special project for freshmen. If they have done 3-4 classes in chemistry, they're ready. And I have done maximum those after general chemistry. They do their own dissertations. These are individual student-based projects in lab, or sometimes when the pandemic was going on, I had it over literature-based, but it's much more involved than the traditional, the previous ones. They will have a lab they will have to set up the experiments. They will have to have the critical skills to go ahead and do the lab, learn the skills. And of course, I'm there to scaffold. And then they will learn the experience of doing a mini research work, like a mini dissertation. Students submit the paper, and this is where they do something different. They present their findings to the faculty forum. So faculty is asking them questions. It's almost like getting an experience of doing like a defense, mini defense. A very encouraging environment, at least in physical science, which I know, and the students are just applauded. They are asked questions. They are given that wrestling feeling, and then in the end, they come up with a lot of experience. They grow like fantastically. A lot of students have told me that they applied for the job and they told them about the special projects or undergraduate research, and that's all they talked about. And that they had an experience. Many of them were hired, and of course they were excited to email me about that. These were the designs that have been going on for many years until the pandemic hit. And then I, of course, applied it to that. But let me give you some examples of how literature-based things went. So look at the left side. These are all the curriculum competencies of chemistry. These are actual Gen Chem labs, Gen Chem chapters in the lecture that they do. We teach them all these things. I mean, there are hundreds of such. I just picked out some for this presentation. They study kinetics, they study acids and bases, they study surface chemistry and equilibria, all these kinds of things. And so instead of giving them an exam on that, I made them go through a city of wastewater treatment project where all the reactions that they do to treat the wastewater were asked to be collected. They balanced those reactions. I gave them certain questions on the stoichiometry. I gave them certain questions on how to find out if there were changes, if some water pollution was introduced, how they would handle it, and so on and so forth. For kinetics, some of the students have analyzed data based on a smog episode that happened in California. The latest is acids and base. This student came up with a presentation on ADVOS, which is advanced organ support for the reactions of acid-base equilibria happening in human body during the pandemic patients. And he got a data from somewhere, and he connected that data to these reactions, presented the entire reactions of acid-base equilibria, talked about the equilibrium constant and stuff like that, and also connected it to the pandemic. And there was a big presentation. So this is literature-based, examples for literature-based. The second one was lab-based. And so the lab-based are these. These are the actual labs, again, of chemistry that we actually let them do it. And for pandemic, especially, I was teaching live online. And it was really brutal to give them like a simulating, video and say, watch the burette empty and get the readings. I thought that was too lower level for a Gen Chem class. And so I came up with this labs. We teach them a solubility equilibria lab for an insoluble or sparingly soluble substance. We connected it to calcium stones in the kidney. Calcium stones are nothing but sparingly soluble substances. I made them go through a publication about that. And then we had questions. What is the insoluble substance here? What are calcium stones? How was the solubility equilibria affected? How could we manipulate this equilibria? Gave them a math problem about it, how to solve that. They did something about electrolytic cell. They do electrogravimetry. I told them to do bionic leaf, which is the latest invention about doing electrolysis of water and water splitting reactions. And so this was something that they looked into. Instead of doing a video on the lab, I made them go through this publication, and they completely chewed apart that publication and answered all those questions that I had made for them. So it came as a literal boon for pandemic times for me. I completely pushed this, got a great feedback from students saying, wow, we didn't know how the live online lab would go in chemistry, and these activities really made a difference. So this was again another publication on using spectrophotic determination of iron for rice and maize samples in some place in Nepal. And so I gave them that paper and said, hey, look through this. And then again, scaffolded them with questions. So this is how I created the assessments which connected the real life examples or real life happenings to the knowledge base or the competency we want to go through. We want them to learn. So this is the example of the bionic leaf thing. These are the questions I would scaffold, for example. We have to teach them what are reduction reactions. We have to teach them what are catalysts. What is everything that I question is something that they need or they have studied at some point. And so at the end, they will summarize the article. So it helps them to look through this complicated article by looking at the questions. So they want to find the answers. So at the beginning becomes easier. They don't get overwhelmed. They want to look for the answer. All I tell them is look for the answer. And once they come to question number 4, for example, they have understood it so well, they have branched out. And I tell them the second thing to do is keyword search. So they will look for redox reactions in bionic leaf. Those are their keywords. And so not only this publication, but they will do cross-referencing with other publications. They just go. All I have to tell them is make sure you're not wasting your whole day on this, because it's exciting, and you will know next thing you know is the day is finished and you have other subjects to study. So they get so involved and engaged. I have to tell them, just keep track of time. And if they start from 1 and go to 4, the summary part, by the time they come to question 5, they figured it out. They understood that so well. They wrote beautiful summaries. And I have some really good examples of publications with a lot of good feedback from students. Another example is spectrophotometry. They do this lab. They understand what's Beer's law, what's absorbance, but instead of telling them theoretically and showing them a graphical simulation, I gave them this paper to read and actually told them, hunt out what was their lambda max, find out what was their absorbance, what is the color of the solution, what was all those kinds of things, which creates that critical analytical thing in them, critical thinking and research germ inside them. And plus they link it to the new happening of the world. So what were my observations? The grade A students who opted for this option, that was a brain booster. They were like, VA, something new to do, because they are good at exams. They are doing A's already, but they want to do something differently. So it acts as like a reprieve, like a change. For grade B students, I saw their confidence level go up. Most of the students who did lab-based undergraduate research were from the grade B. And they bettered their understanding, which was seen in their homeworks. Their points increased, which was seen in the way they wrote their answers and also in the exams. So definitely a lot of grade B students went to top D. Grade C students, my observation was the biggest hindrance was time constraint, because they were either working and doing too many things, or they had inefficient study habits like spoon feeding. And when I told them, I'm not going to spoon feed, but I'm going to help you, but I'll give you 2 weeks to do this. So you don't have to do the exam today. Just let's start reading, email me back and forth and tell me where you're stuck and we'll work through it. And they did that. And all these led to many of the grade C students prevented from being dropped out or prevented from being, withdrawing from the class. So some of the takeaways that I heard, I asked the students, like I took an informal survey, and these were some of the things that came up from them as to, I said, hey, you all say you like this, but what was it that you liked? And these are some of the things. I put them in I put them in bullets. The maturity was my observation, that maturity and academic growth was my observation, but they told me that it took off the pressure. They got the sense of achievement. It was a great mention on their resume. A lot of them got asked about this in their job interviews. They showed a confidence in the subject. And then the maturity and academic growth was my observation of them, that definitely they had that. They were a different student by the end of that semester than when they started in the beginning. So these were some of the takeaways. I think they are very important qualitative takeaways, apart from their grades going better and apart from them not dropping out. So I think that's what was my takeaway also. So then the question comes is, if you were to incorporate this, or anybody was to incorporate this, how would you do it, right? It definitely is a unique method. It's an innovation, but it requires a preparation. And what is that preparation? So you will need to do three things. First and foremost, you'll have to keep updating yourselves with what happens. And it doesn't mean hardcore research, big papers of 15 pages. It could just mean a news. It could just mean like a website like Science Daily in science. It's like a simple website. Or it could mean any kind of a blog or any kind of a website which is dedicated to knowledge of science, spreading the knowledge of science. Just keep reading as a lifestyle practice if you are not doing this before. There are ample of them which are non-subscription free. Because if you are to mentor a student with undergraduate research, you have to be a few steps ahead of them in knowledge at least. So you have to be aware of what's happening in your field, if nothing else. Secondly, you must keep in forefront the competencies of your class. That way you don't go just anywhere and go to a level which is not even the level of your class, where they get distracted, they are completely overwhelmed, and they're like, I don't know what this is. I don't even understand the paper. So keeping the track of competencies is very crucial. And then the third and the most important part, which helped me, and I did, is literally weaving these two things, combining these two things. So for example, I read that kidney stone thing, and I immediately realized, oh, wait a minute, I teach solubility product to the students. This is their competency. Maybe I can put those two together. Some doctor is publishing something about his kidney stones in his patients removed by some method. And that was, they were using a chemical medication, different medication than the traditional medication. That medication is nothing but a substance that they learn as chemistry compound. And so I connected those two and I prepared this thing. Or bionic leaf, I read about it, and it is electrochemistry. And I said, wait a minute, they study redox reactions. I coupled the two. So putting the two is what I mean by finding the match of the above two. And that's where the assessment questions are being born, or the assessment is being born. So you can also put comprehensive questions, the assessment into comprehensive questions like A, B, C, D, E, or putting it all into one question, taking from different authors. But definitely keeping 1, 2, and 3 is very, very critical. Some of you may want to see if it can be applied. So for example, this bionic leaf and this kidney stones can be applied in real life. But some of your disciplines may be like philosophy, may be different. So the last bullet is not mandatory. It can be just a fundamental research which hasn't found any applicability yet. But if you can make it applicable, that really catches them. They start feeling very empowered and, oh, so this can be done. I never knew that we could do this. And so they get into that zone. And then after that, you don't have to do anything. They are on their own. The fire is lit already. And that's what my experience was. So these are some of the preparations which absolutely are required if anyone has to apply undergraduate research as their assessment. And I think we typically read, as being in the faculty academia, we are readers. But if we can read with respect to these competencies in mind and combine the two, there gets born an assessment which is very valid, which is very authentic, and to the level of that student. So some conclusions I have are, these projects can be generated from the curriculum, which demand critical thinking, and they are literature-based. So if you don't want to go to a lab and don't want to do a project, give them literature-based projects. They will be sitting in the library, or they'll be sitting on internet and figuring it out. And this Gen Z is absolutely enamored by internet. So if you give them anything to do with internet, they will be completely engaged and honest about it. which is my observation again. So this is literature-based thing. Then as far as the lab-based or special projects, you can always use questions in mind and create new designs, and you can orchestrate them. Of course, you need to scaffold this. I call it scaffolded world of unknown, which means it's a world of unknown. It's a dark thing. They will ask you, so what is expected result? And you say, well, we have to see a pattern. You do it 10 times, and then if you 10 times get some result, which is concurrent, you got a pattern. And so that's what then starts thinking that, okay, so this is something new, but I have a support. I have a pattern support. I have she looking on to my work. So that's what is, they like it, and it is possible. And then you can also tweak the given lab. Like I said, regular labs, you can extend the, have extensions to the regular labs, or you can have extension to your regular actual class, something like an honors element, but not to that level where it, honors is typically coming from the student. Here you can generate ideas. Sometimes even students will come up with ideas, and that can be weaved as a replacement to the one of the exams or replacement for a quiz, and instead do this project. And they do that. However, they must write a paper. They must answer those questions so that you can grade it objectively. For the pandemic, though, it was a boon for me. I couldn't have expected anything. So if designed well, that means by keeping in mind the reading of your subject and keeping in mind their proper competencies, if you make a match, that means if you design it well, qualitatively as well as quantitatively, all the results are encouraging. Qualitatively are all the high impact indicators. Quantitatively, their research, their results, their grades, and the fact that the grades are better, they're not dropping right now. They're staying in your class and completing it. Those are some of the results that are encouraging to believe that this method can be a rewarding assessment practice. So if you want to design an activity, what would be fitting your subject or your class? Maybe you want to do descriptive research. Maybe you want a longitudinal research, or maybe you want to do a mixed research, whatever is required. You can have either literature-based project, a lab-based project. You can have a cure section. That's the entire section that we talked about. Or you can have your own design. But if you keep those three things in mind, you can soar high and create any kind of activity, which I feel. So I have some credits to citations. These are some people I follow and read. And then these are some of the things that I would leave you with is these quotes on growth. And thank you for being here this afternoon.